Hello there, it's exercise 2A. We're going to look today at the mean and variance of discrete random variables. Now, discrete random variables we've already seen in normal A-level maths. This is a part of that course which is based on statistics, and we've seen this already, and I suppose I need to remind you of that. But before I do, can I just point out that there's a reason why there's a picture here which is all to do with cards. That's because a lot of probability questions are to do with games of chance, so you often get dice, which everyone's fairly familiar with, but cards perhaps less so. Less people tend to pay cards now. So you should be aware, for instance, there's 4 suits, and they are hearts, diamonds, clubs, spades. And these, you should realise, are both red. These are black. What else do you need to know? You should know, for instance, that in any of these, there are 13 in each suit. 13. Now obviously 13, I've already said there's 4 suits, so that's a total of 52 cards in a standard pack. And the last thing I'll say is obviously you should know that there's 1 up to 10, and then there's a jack, a queen and a king, and the 1 is sometimes called an ace, or very often called an ace. Sometimes if you're playing cards, you'd care about whether that's a high card or a low card, but broadly speaking that's the kind of stuff you should know. Anyway, well, I'm sure we'll see questions like that in due course. Find the value of k for this probability distribution. It's a simple starter. We've seen this in normal maths, something very similar to it anyway. So look, the first thing you've got to do is work out what k is, because it doesn't tell me what the probabilities are. It tells me it can only take certain values. It seems that it only takes the values 3, 4 and 5. But other than that, it doesn't give me the probabilities. But we know the probabilities always add up to 1. So the sum of all the p's has got to equal 1. So if I go 14k plus 4k plus 2k, that must equal 1. Add up all the probabilities. And I reckon that's 20k equals 1. So put a different way, k equals 0.05. So if k equals 0.05, what's that mean? Well, it says it wants me to work out the probability of this. Well, I can quite quickly just times that, all of these by 0.05. So 14 times by that, I think is 0.7. I think this is really 0.2. I think this is 0.1. At least I've got proper numbers now. What's it want? The probability that x is less than 4. Well, to get less than 4, this is the probability that x is 3. Or, I suppose, so I'm adding the probability that x is 4. So I think the answer is 0.9. 0.9, yes, got those right. So the mean of a discrete random variable. So there's a formula for working out the mean. You think of the mean as an average value that you'd expect to get. So if I'm looking at this example here, now obviously, then if they're all equally weighted, you go the average of 3, 4 and 5 is 4. But they're not equally weighted, i.e. we're much more likely to get the 3 coming up. It's got a probability of 0.7, but the 5 hasn't got a probability of 0.1. So if I was to try to work out the average of this, well, just think for a moment. I've got 3, 4, 5 from this example just now, and 0.7, 0.2 and 0.1. So whatever I do, this is x and p if you like, whatever I do, I've got to take that into account when I'm working out the mean of this, the average value I'd expect to get if I was to take, to do this. And here's the trick, you just multiply these together, a bit like you did when you was finding the mean of a frequency table. And if you do 3 times 0.7, you get 2.1, plus 4 times 0.2, that's 0.8, 5 times 0.1, that's 0.5. Now if I add those together, I get 3.4. Now, does that mean the answer is 3.4? Oh, it seems reasonable actually. It doesn't look 3.4 fits the bill. It's in between 3 and 4. It's closer to 3 than it is to 4. It's way away from 5. So this looks quite reasonable. And this is actually the right answer. We call this mu. Sometimes it's called E of x. It's got a couple of symbols that we can use. So the way we did that was similar to what you'd do if you was finding the average of a I don't know, perhaps you're doing an experiment. You're doing an experiment 50 times. So n equals 50. Then maybe the probability of success is 0.3. And just by following this formula p times n, you say 3.3 times 50, well, I expect to get 15 of them. And it's a similar thing, but because there's more than one thing, we have to do it for each one. And so if you do this, this is the posh formula, E of x, the expectation is a posh name for it, or the mean, both, or the average, yeah. And basically you do this, this means the sum of all the x times the p's. Now we pronounce this then mu. Look at the way I've written it, mu, that's how you pronounce this. And essentially you'll notice I'm timesing all the x values by all the p values, all the x values by all the p values, until you run out of them to do, and I've just written this as mu xp. The i's don't really matter, it just refers to there's lots of individual ones. So it's a three-stage process for finding the variance. So I've so far shown you how to find E of x. This is the average, the mean. But there is another thing called the variance, and the var of x as we write it. I suppose we've seen the variance in normal statistics, and it's quite similar. And you can also think of this as the standard deviation squared again, in the same way as it is in normal maths again. So first job for finding the variance, if you want to find the variance, is we have to find the mean first. So find the mean. Second job, find E of x squared. Now that's actually easier than it looks, and I'll show you how to do it in a bit. Third job, use this formula, write this formula down. The var of x is E of x squared minus E of x squared. Okay, that actually makes more sense. I'll show you in class why that makes more sense than it perhaps at first appears. But that's the formula that you need to write down. The data book shows it slightly differently. It talks about sigma squared. So when I say the data book, this is the formula that generally appears in the exam. So we'll have to have a look at the formula to make sure you're familiar with it. But this is how it appears. But this is what I want you to learn and remember and use. Let's use it now. I've got it at the top of this now. I've written these in fractions. I don't particularly like the fractions. I suppose you could just convert these 0.1, 0.2, 0.3, 0.4. That's probably easier for the probabilities. And they're very nice, aren't they? It's a very simple one. Now look, I want the mean and the variance. So let's go through this as a three-stage process. First step, find E of x. And E of x is where I multiply these like this. So I do 1 times by the 0.1 plus, notice I'm adding these as I go, the 2 times by the 0.2 plus the 3 times by the 0.3. They're very nice. All of them agree with each other, don't they? 3's where 3's are. Plus 4 times by 0.4. So if I just type this in my calculator now, so I've got 1 times by 0.1 plus 2 times by 0.2, or that's obviously 0.4, plus 3 times by 0.3, that's 0.9, and 4 times by 0.4 is 1.6. So adding those together, I got exactly 3. Okay, I didn't expect the whole number, but there you go. So I've got my 3. Now here's the thing that's less obvious, but quite easy. E of x squared, basically, well, last time I did the x times by the p. That was for E of x. But if I want E of x squared, I do x squared times by the probability. Notice the probability I don't square, I just square the x. So 1 squared times 0.1 plus 2 squared times 0.2 plus 3 squared times 0.3 plus 4 squared times by 0.4. Again, no idea what that is. Well, 1 squared times 0.1 I know is 0.1 plus 4 times by 0.2 plus 9 times by 0.3 plus 16 times by 0.4. Again, no idea what that is. It says 10. Again, I didn't expect a whole number, but I've got a whole number. You won't always get whole numbers. Now, using this formula then, I can now calculate var x. Var x, variance of x, is that 10 minus this 3 squared. And 3 squared, of course, is 9, so 10 minus 9 is 1, another whole number. Perfect. So, what's my answers? Mean is 3, E of x squared was 10, and the variance is 1. Perfect. Got to do the same thing for these. So I've got, well, this is again, well, this one I'm going to have to do as fractions. So E of x equals, just times them together. So it's 1 times a sixth plus 2 times 2 sixths plus 3 times 3 sixths. I obviously didn't want to make the numbers too hard when I did this PowerPoint. That's a sixth plus 4 sixths, that's 5 sixths, there's 9 sixths there. I think that's 14 over 6, which is 2.5, I think. Is it 2.5? No, it's not. It's 2 1/3. 14 divided by 6 is 7 thirds, 2 1/3. So I've got my 2 1/3. It might be better actually writing it as 7 thirds. Now, next job, e over x squared. Notice the squared in here. So again, I do 1 squared times a sixth plus 2 squared times 2 sixths. I don't know what I went wrong there. Plus 3 squared times 3 sixths. Alright, so what have I got? I've got a sixth plus 8 sixths effectively plus 27 sixths, I think. And I get exactly 6 when I do that. So for my last job now, my variance of x is that 6 minus 7 thirds. And notice that I can't just write 7 thirds, I've got to square it. So minus 7 divided by 3 squared. I get 5 ninths. Should always be positive, so if you ever get a negative, you know you've done it wrong. Quick look at the answer. 7 thirds and 5 ninths, good. The other one came up, but I didn't see it, luckily. So the next one, e of x equals, well, 0 times, well, that didn't do much, but that's what you have to do. 0 times by 0.3 plus 1 times by 0.1 plus 2 times by 0.6. What's that, 1.2? 1.3 I get. Now I do e of x squared, and I just square this. So it didn't make much difference on the first one, nor the second one actually. The only one it changes really is the fact that it's now 2 squared times 0.6. That's 4, that's 2.4, I think that's 2.5. Now to work out the variance, I do that 2.5 and I take away 1.3, notice I have to square it. Now 1.3 squared is 1.69. Do it properly on my calculator, I get 0.81. 0.81. Good, I got 0.1. Yes, everything's perfect. We do already check that. And I've got one last question for us to do before I then let you do some work in class effectively. Now, first of all, it says I've got P and Q here. All right, so it's a bit naughty this. I don't know what P or Q is, but I do know they all add up to 1, so I suppose I can do that. What do those other numbers add up to? 0.15 plus 0.21 plus 0.13 plus 0.07. So I've added up all the others, and I get as a decimal, if I add up all these, I get 0.56. But don't forget, I've also got the P and the Q, and they all have to add up to 1. And I suppose that's really telling me that P plus Q is 0.44. Now, if I do the multiplications, I get another statement. What do I get? I'm just going to do it 0.5 times 0.15 plus 1.5 times by 0.21 plus, I'll ignore those P and Q's, 4.5 times by 0.13 plus 5.5 times 0.07. So more than them all out, I get 1.36. But don't forget, I've missed out the 2.5 times by the P plus the 3.5 times by the Q. And it tells me what the answer is when you're doing this. It's 2.61. So when I'm finding this E of x, this is what I get. Now I'll tidy this up a bit. I get 2.5p plus 3.5q. And if I do the 2.61 minus that, I get exactly 1.25. Now notice I've now got two simultaneous equations. Now these two simultaneous equations will be able to be solved. Now I'm not going to solve it now, I'm going to wait, I've run out of time, but this perhaps highlights what we have to be able to do. We'll finish this in class, and in class we'll then go on to exercise 2a. This is the mean and variance then of a discrete random variable, and I'll highlight this formula for you again here. We're going to use it loads. Good luck.